All right, so Unit 1, Lesson 2. And so this one's just about adding and subtracting, like I said. And what you're going to do is you're going to go through, it wants you to use your calculator. Okay, and it wants you to just try to investigate whether these are true or not. Okay, so what that means is you're going to put this one in your calculator, and then you're going to put this one. You're going to see if they're equal. Okay, et cetera, et cetera. All right, and as I talked about last class, remember, radicand is the number inside the radical. Okay, so the 2's. The 2's are the radicand. Okay, the index is the root. So what I mean by that is, this one, if there's nothing there, it's a square root. So this is a 2 here. Those are 3. Those are the indexes. Over here is 3, 5, etc. Okay. In order to add and subtract radicals, they have to have the same radicand and the same index. Okay. So I want you to think about it as like terms. So this means like, this is like 1 root 2 plus 5 root 2. Well, that's like 1x plus 5x. 1x plus 5x is 6x. Okay, so that's why it's 6 root 2. So this one here is correct. Circle that one in green because it's correct. Same thing here. Index is 3. Root 5, root 5, root 5. Okay, 4 minus 7. 4 cube root 5 minus 7 cube root 5 is negative 3 cube root 5. So this one also is correct. Okay, and the last one here. Same radicand, same radicand, same radicand. Root, root, root. They're all 2's. If nothing's there, it's a 2. Just a square root. Okay, 5 minus 2 is 3. Plus 7 is 10. Root 8. That's what's here. So this one's also correct. Okay, so that means we have all 3 of those correct. So the ones to the right, we can probably go ahead and assume, but they'll probably be incorrect. So we double check that. So the ones to the right here, I have 7 root 5, 7 cube root 5. So the difference here is the cube. Okay, so the cube's the issue. Okay, you can't add indexes. That's what they did. They went 2 plus 3. You can't add indexes. So this one here would be a no. So I've crossed this one off as you can't do that one. Okay, this one, they all have the same index, but they have different radicands. So that's the problem right here. We can't add radicands, so this one's a no. It says use the results to suggest a rule for adding, subtracting radicals. You can add and subtract radicals when you have the same index and radicand. That's what I put for that. So you can add, subtract radicals when you have the same index and same radicand. Has to be both. It's not a one or the other. It's a package deal. Okay. All right. So now we're going to simplify the ones here at the bottom for part C. All right. So part C. To simplify the following, so we have 8 root 7 minus 3 root 7, so that is going to be, this piece is going to be 5 root 7, and we're going to add 15 root 7. All same radicands, all same index, 5 plus 15, 20 root 7 is that one's simplified answer. Okay, got any questions so far? Are you okay? Okay. All right, so then the next one, I have 5th roots, so I'm good. All the same index. Radicands are all 10. 18 plus 12 is 30. 5th root 10, so 5 there. Minus 7 5th root 10 gives me 23 5th root 10. So that's that one's answer. And the last one, 5 root x minus 4 root x is just root x. Or you can put a 1 there if you want, but you don't have to. Okay, investigation 2. All right, so you use the calculator to prove that these are true. Well, these are true, and the thing is that our rule from before, which we're going to alter here on part B, is that from lesson 1, we learned how to break down radicals. Well, 8 can be broken down to 4 times 2. Well, that gives me root 2 plus 2 root 2. Well, what's 1 root 2 plus 2 root 2? Well, 1 plus 2 is 3 root 2, and that is why it's equal. Okay, so if you simplify, you can kind of change things or alter them so that it works in terms of being able to add or subtract them with the same radicants and indexes. Okay, so this one here, they're all different. Well, let's look for something with a 3. Well, 4 times 3 works. 16 times 3 works. Okay, just know that from my perfect squares. So 4 comes out as a 2. That leaves me with a 10 there. So this turns into 10 root 3. This comes out as a 4. That gives me 24 root 3 equals 34 root 3. Well, we just kind of proved that. 10 plus 24 is 34. So just to top it off, 34 root 3 equals 34 root 3. Ends up being the same. Does this appear to contradict the rule you had in investigation 1? It does in terms of the beginning, but at the end of the day, we still need same index, same radicand by simplifying. That's the difference. We'll write that in green so it makes it a little bit more important here. Okay. Okay, complete the following by, and we kind of just did this already, so I did above. So we're just kind of breaking these down. So this breaks this down to 4 times 2, makes it 2 root 2, okay, which equals 3 root 2. It's kind of a little bit step by step. This gives you 4 times 4 times 3 plus 6 times 16 times 3. So that gives you 10 root 3 plus 24 root 3. 34 root 3. We already kind of at the top, just kind of redoing it. A little bit more space. Okay, all right, we just got one more page, well, a little bit. One more page, a couple examples. So here's the rule again, that in order to add and subtract radicals, they must be able to be expressed as like radicals. Like radicals means same index, same radicand. We said that 20 times now, I'm probably tired of hearing it. But so example 1. So write each expression in terms of a single radical. So what we have to do is we can't go 80 minus 20. That's been established. So the first thing I want to do is I want to try to get them to have the same radicand. So we're going to simplify and see what happens. So 80 breaks down to 16 times 5. I choose 16 because 16 is a perfect square. Okay, the 16 comes out as a 4 root 5. 20 breaks down to 4 times 5. The 4 comes out as a 2, minus 2 root 5. 4 root 5 minus 2 root 5 is 2 root 5. Okay, and that's the answer. That's all we can. I mean, the goal was to get this right here where they have same radicand, same index. We did that. Now we can combine them. Okay, next one. Now we're dealing with cubes. I know a little more difficult because we don't know them as well, but we do know that 8 times 10 is 80, and we know 8's a perfect cubed. And then we're going to steal the 8 times 10, well, 27 times 10, because 27 is a perfect cube. Okay. Cube root of 8 is 2, so I get 2 cube root 10. Cube root of 27 is 3, so I get 3 cube root 10. Now I have like index, like radicands. I can put these together. 5 cube root 10. Okay, one more before we get to the messy ones. Okay, we'll break these ones down as well. It's all about breaking them down. I got to take them piece by piece. So I'm going to go 9 times 3 because this is square root, so I'm looking for perfect squares again. Got to switch back to square root mode. This is 25 times 3, and then this is 49 times 3. Okay, if you're not recognizing which numbers go in, remember, take your perfect squares that we talked about, the 1 through 15 perfect squares, take whatever half of 147 is. That's about 73.5, so say 73. The closest perfect square to that is 64. Try 64. Doesn't work. Try 49. Oh, that one worked. And then just go from there. That's what I always do. I come and start halfway, and then I work my way back. So I pull the 9 out. That comes out as a 3. 7 times 3 is 21 root 3. The 25 pulls out as a 5, so it's a minus. So that's a 5 times 3 is 15 root 3. And then the 49 comes out as a 7. 2 times 7 is 14 root 3. 21 minus 15 is 6. Plus 14 root 3 gives me an even 20 root 3 to finish. Everything still good? Good? Okay. All right. So, example 2, a little messier. We got fractions now. So we'll do the first one. So 108. Trying to think about perfect square goes 108. Again, just because I know my perfect squares, you'll find it eventually. It might take a little bit longer, but 36 times 3 is the perfect square we want there. The other one is going to be 8. It can only be 4 times 2. So this one you might notice, well, these both don't end in 3. So at the end of the day, we're going to have a root 3 and a root 2 in our answer. And we're not going to be able to put everything into 1. So we have to kind of accept that, and that's okay. 16 times 3, 25 times 2. Okay, I'm going to pull the 36 out. Gives me 6. Negative 5 times 6 is 30, root 3. I'm going to pull the 4 out. 4 times 3/4, the 4 cancels. Oh, excuse me, it's got to be a 2. That's not right. Pull the 4 out, it's going to be a 2. 2 times 3 is 6, because it's 2 over 1, because we're multiplying. 6 over 4, so it's going to reduce to 3/2. Root 2. And pull the 16 out. This is what I was thinking. And it's going to be a 4. That cancels with this 4, so it's just minus 5 root 3. Okay, and then the other one here, I'm going to pull a 5 out. I'm going to go 5 over 1 times 1/2 equals 5/2 root 2. So we can combine this one and this one, this one and this one. Those are the ones we can combine because they have the same radicand and the same index. And you take the signs in front of it. This is a negative 30 minus 5. That's a negative 35 root 3. Okay? And then 3/2 root 2 plus 5 halves root 2. Well, just go over here. Well, what's 3/2 plus 5/2? Well, they already have a common denominator, so that's nice. It's 8/2. Well, that's just 4. So the answer here is going to be plus 4 root 2. So that's that one's complete answer there. Okay, still good? That was a little harder, right, because the fractions? Okay. Is there any questions you have on it? You sure? Okay. All right. Well, we'll look at that in a second. All right. So, all right, let's do B. Let's make B. B's a little bit harder because it's got cubes. But, all right. So, cube root of 64 is 4. And again, you put that in your calculator, and it could tell you that. So, if you put cube root 64 in your calculator, it'll kick out 4 for you. So that gives me 4 over 8. I'll just leave that as a 4 over 8 for right now. Cube root of 375. Well, cube root of 375 is going to give me, let's see here, I want to break that down to 125 times 5, because 125 is a perfect cube. 125 comes out as a 5, so it gives me 2 times 5, which is 10. Cube root 5 is left. Cube root 3, excuse me. Because 125 times 3 is 375, sorry. Can't read my own handwriting. Okay, the next one here, cube root of 54. We're going to break that down to 27 times 2. 27 comes out as a 3. The 3's will cancel, so it's just going to be minus 2 cube root 2. Okay, and the last one we're going to simplify, 24 is cube root. We want to take the 8 out. That's the best cube there. Comes out as a 2. Again, the 2's cancel, so I get minus 5. Because the 2 comes out, it's going to cancel with that 2. I still get the minus 5 root 3 with the 3 left over. All right, so we go here and we look. We have this and this are in common, so let's put those together. 10 minus 5 cube root 3. So that's going to be 5 cube root 3. 4/8 reduces to 1/2. We'll leave that 1/2. That has to stay. Nothing can happen to that. And then that'd be your answer there. Just a lot of fraction work there. All right, we will end it there, and we'll do the next one in class tomorrow. Okay? All right.